Okay, we're going to work on doing some operations with matrices, addition, subtraction, multiplication, all kinds of fun stuff. Um, we will look at whether two matrices that are given are equal. We'll add and subtract matrices. We'll multiply matrices by real numbers or scalars, and we'll also multiply matrices together, one matrix by another, and then we'll look at solving problems. Adding and subtracting matrices is very easy. All of you do, first off, you need to have two matrices that are of the same dimensions. And when you're adding and subtracting, you are just adding or subtracting the corresponding elements of those two matrices. So if I have a matrix 1, 2, 3, 4, and I'm adding matrix 5, 6, 7, 8 to it, all I do is I add up corresponding elements. So 1 plus 5, 6, 2 plus 6, 3 plus 7, and 4 plus 8. And that would be my matrix addition right there. Okay, subtraction works the same way. I just subtract the corresponding elements. And scalar multiplication, if I were to multiply a scalar times a matrix, all I do is multiply each of the elements. So 3 times 2, 6, 3 times 4, and so on. Okay, so there's addition, subtraction for that matter, and scalar multiplication with matrices. Here, the first thing I would do if I was given this problem would be to check to make sure that the matrices are of the same dimensions, which they are. To add A plus B, I just add the corresponding elements. Okay, I'm not going to do the whole thing, but that would give me 6, 0, negative 13 as my first row. And then I would continue down and do the other three rows to come up with the sum matrix. If two matrices are equal, then they have corresponding elements that are equal. So 4 is equal to 4, negative 3 is equal to negative 3. Every single one of them has to be equal. Okay, if all of them but one are equal and the last one is not, then they're not equal. But in this case, these matrices are equal. Looking down here, the elements don't look the same. Okay, 4 and 3 plus 1, they don't look the same, but 3 plus 1 happens to equal 4, of course. 4 minus 7 equals negative 3, and if you check all of these values are in fact equal, so the matrices would be considered equal. We could use matrices. If I know that these two matrices are equal, which is what is indicated here, I know that the corresponding elements are equal. If I want to find each variable, well, I could set up 4 equations. I know that these elements are equal. A plus 1. Whoops. Hang on. Try this again. What is this doing? Good God. A plus 1 equals 7 minus A. Okay. And then I could solve that, of course. I could add A to both sides. I get 2A plus 1 equals 7. Subtracting 1, 2A equals 6. Okay. 2A equals 6, or A equals, oh my gosh. A equals 3. Simple as that. I don't know what is going on with this pen today. Anyway. And I could do that and set up a similar equation for each of the other corresponding elements. Draw lines all over the page too. Interesting. Of course, we could do this on the calculator. So, what I'm asked here is to compute 3A minus 2B. And I can do this. I can write out the matrix 3 times A and 2 times B and then subtract them. Or I can kind of do it one at a time and say, okay, 3A, that would be 3 times 3 minus 2 times negative 8. So 9 minus negative 16 is going to be positive 25. And I can figure out each element manually. Or I could use the calculator. Okay. And let's turn this on. Maybe. All right, the calculator is not cooperating. Let's try that again. All Right, we're going to make this a little smaller. Okay, let's clear this. Okay, so now I'm going to go in and I'm going to enter two matrices. Second matrix, edit. And I'm going to use matrix A again. I'm just going to go right over what's there. This is a 2 by 3 matrix this time. So 2, enter, 3, enter. And I'll just enter my numbers. 3, 7, -1, 9, 11. Okay, so there's matrix A. And now I'm going to quit out of that. It saves it for me. Second matrix, I'm going to go ahead and edit and create matrix B as well, which is also a 2 by 3, which is important since we're doing some addition and subtraction on these. 2 by 3. And that's going to be -8. 3, 3, 12, 0, and -54. Okay, so now I have my two matrices in there, and just to remember what we were doing, 3a minus 2b is what we're looking to do here. Okay, so I'm going to go to second, well actually cancel that. Before I do that, I'm going to put in my 3 times second matrix, and I'm going to select matrix A, minus 2 times matrix B, second matrix, and select B. So there's my function. Hit enter, and it gives me my solution matrix. So that's how you work it with the calculator. Okay. Properties of matrix addition, scalar, and multiplication. I'll let you review these. They're all should be similar and familiar with what you've seen before. Okay. Now, I said before that there wasn't matrix division, and we've got an equation here that looks like, in order to solve it for x, and notice that these variables are capitals, meaning that they are referring to matrices. It looks like we're going to have to divide, but really what we're going to have to divide by is 3, which is a scalar. That's okay. That's the same as multiplying by 1/3. Okay, so if I write out this equation, 3x plus a equals b, or not. All right, that equals b. We're going to solve this like we would any other algebraic equation. I'm going to get x and isolate it. So I'm going to subtract a from both sides. I get 3x equals b minus a. And then I'm going to divide both sides by 3. So I get x equals the matrix subtraction b minus a over 3. b minus a divided by 3, which is the same as 1/3 times the quantity b minus a. Yeah, matrix multiplication is a little bit of a different beast in that you do not just multiply the corresponding elements. It sounds a little complicated, but what you're going to do is you're going to go across and down the matrix to figure out what you need to do. You're going to actually multiply the elements of each row in the first matrix by the column of the second matrix and add up those products. Let's do one. It'll make a lot more sense once we do it. Let me just move this up. Okay, so we're trying to get the product of these two matrices, and we're going to do it one element at a time. Okay, the first element we're going to go after is this top left one here. Okay, so I'm going to look at the top row and the left column, and I'm going to go across and down. And to do that, I'm going to say -1 times -3, the first number in each pair, okay, plus 0 times 5. Okay, we kind of multiplied across and down. And you just got to look and see that pattern. It works the same no matter what the dimensions are or what matrix you're multiplying. Okay, so -1 times -3 is 3 plus 0 equals 3. So our first element, that top left element, would be 3. To go after this one, the top right element, I'm still going to be going across the top row, but I'm going to be going down the second column. So -1 times 3, which is -3, plus 0 times 0. Okay, that element would be -3. And you go and do that for all of the elements in your matrices. Okay. So let's go ahead and do this. Find the product. And I'm just going to create a solution matrix here. Okay, we're going to go across and down. So -3, okay, times -1 is 3. And I'll just jot it down over here. Or not. 3 plus, okay, 3 times 3 is 9. This is ridiculous. Okay, this is totally not working. All right, so that first element will be 3 plus 9, which should be unable to be entered, apparently. Wow, this is just completely conked out on me now. All right, well, you got the idea. See, I've lost my cursor. There it is. Okay, so let's edit, clear all that. Let's try this again. This is bad. All right, what did I say? 3 plus 9 is 12. Okay, let's go for the top right element. It's going to be -3 times 0. Okay, because we're going across this top row and down the second row, the second column, I'm sorry. -3 times 0 is 0. 3 times -4 is -12. So this would be a negative, if I could find my cursor again, -12 over there. And I know that's a little hard because of this mouse not working properly. And you'd complete the rest of the columns the same way. So you'd go across the bottom row, down the first column, and across the bottom row and down the second column for these two elements as well. Oh, that was great. Okay, go ahead and practice that. Now, it's important when you are multiplying matrices that you have matrices that are of appropriate dimensions. Here, can I multiply this? Can I go across and down? Yeah. Okay. This is going to give me a value. 12 times 10 is 120, plus 3 times -5 is -15. 120 minus 15 is 105. And that is the solution. It's not a matrix. It's just a scalar, just because of the shape of these matrices. You cannot necessarily multiply every matrix by every other matrix. They have to be of the right dimensions. Okay? Could I multiply this? Well, what the problem is, if I try to go across and down, I go across 10 times 12 is 120, but now I run out of numbers. I don't have anything to multiply by this 0, and I need to. Okay, so these two matrices cannot be multiplied. And as a general rule, the dimensions of a matrix, look at the red first. You have to have your across, your number of columns. I have 2 columns going across, 1, 2. Okay, that has to equal the number of rows, so I can go across and down and have numbers to multiply. If those two values are equal, the columns of the first matrix is equal to the number of rows in the second matrix, I can multiply them. Okay. The dimensions of my product matrix is going to be the number of rows in the first matrix by the number of columns in the second matrix. And you could either remember that, or you could just do the multiplication and look at your solution. Okay, and of course you could do these on the calculator as well. Okay, we'll do those in class.